So, hello everyone to the Universe Moment interview with Mrs. Taylor. Nice to meet you.
Hi, thanks for having me.
So, we'll talk about the first year of James Webb Space Telescope science observation. And we all know the power of this telescope and its capabilities, right? Now, how has the James Webb Space Telescope's imaging capabilities evolved over its first year of operation, and what technical advancements were key to achieving such detailed views of the Ophiuchi cloud complex, which is even in my background?
Yeah, I love that you have it as your background. It'll be great for referencing. Yeah, this observatory is amazing, and the skills that went into just the feat of engineering that is this observatory is really beautifully portrayed by the Ophiuchi cloud that you have behind you. One of the beautiful things about this observatory is people often compare it to the Hubble Space Telescope, but they're not really in combat. They work beautifully in tandem together, and so they would look at different kinds of light. But one of the really beautiful things about the JWST is that it's even bigger in the mirror size, and it has the newer technology on it. And so it's able to peer further out in space and to a much better resolution and just like this beautiful crispness of detail. And it really has revolutionized so many different fields of astronomy just because of how amazing it is.
Yeah. And also regarding the image, most of the people probably wonder that the image captured by Webb shows huge bipolar jets of molecular hydrogen. Can you tell us a little, how do these jets form, and what can they tell us about early stages of star formation or even probably planetary formation around the stars?
Yeah, so yes, so what you're seeing, I mean, in the image behind you is kind of about a massive complex of star formation. And so you have about 50 young stars that are forming of various sizes, some of them very close to the size of our sun. And yeah, so these vertical and horizontal bands of just what look like lava in this image are these molecular hydrogen jets. And they're really the result of these really big stars that are forming and in the process of forming. And so what's really beautiful about when you have these stars that are beginning to form is they're kind of accreting in, particulates and matter and creating these big stars and also creating planets at the same time, potentially. So we have these things that we call protoplanetary disks. And so what's really beautiful about this is that you have these incredibly chaotic active systems happening, and you're kind of seeing the result of that with these massive jets that are kind of spewing out as it's being formed.
So actually, these stars may have been formed just like our star, the sun, and even the
Exactly.
disk around them with the planets probably that will, I hope, will be discovered in the future by Webb.
Yes, exactly.
And another important thing is the star S1, which stands out as significantly more massive than the others in the image, all other stars. Well, how does the star's mass impact its surrounding environment and the formation of nearby stars? Because it's very massive.
Yeah, so it definitely, actually my favorite part of that image is unfortunately right behind you. it's the really bright white region, and it's showing like a star that's a little bit more massive than our sun that's forming and kind of clearing out the area around it. And so when you have these incredibly massive stars forming, you do start to have this blowing out of the material around it. And so you have this essentially these little caves that form inside of these star forming regions. And it's kind of this, it's part of that process. And so what's really interesting is that, as you have these really massive big stars forming, they are so bright and they're emitting so much powerful radiation that it's really easy to find them, first of all, if you're looking with, a really powerful telescope like the JWST. But you also can find them in these regions, and you can see literally in this image the impact that they're having on their surrounding area. Like in the top right corner of that image, you have stars that are a little smaller than our sun that are kind of really baby stars enshrouded in clouds of gas and dust, and you can't really see them very well. We can kind of peer into it with JWST, but with these more massive stars, you're seeing the impact that they have in this environment.
Sure, and that is why James Webb Space Telescope was built, and that is why we observe all these things. Now, a general thing about Webb is that its ability to observe distant galaxies near the dawn of time that has Webb provided. A question is that, has Webb provided any new insights into the universe's condition and processes that shaped its evolution other than what we already have?
That's a fantastic question. Yeah, I love that you asked this because this is a type of science that I study, and so I'm really passionate about it. Yeah, so one of the four main science cases for JWST was to find, the most distant galaxies and like really push that boundary of how far back in cosmic time can we look. And so I think one of the really beautiful things is first of all, this telescope is just amazing. The imaging abilities of it, to make these beautiful crisp images that we've seen, but also the spectroscopic capabilities. And I kind of describe that as like a light fingerprint. And so, we have the electromagnetic spectrum, and you could take a light fingerprint of any of these cosmic objects, and it tells you the chemistry of these galaxies and what's going on inside of them and what kind of stars might they have. Are there supermassive black holes living in their cores? All of this really fascinating science that you just really can't get from imaging alone. And JWST is so powerful with this. And so with these really distant galaxies, we've been able to finally get light fingerprints of them. And I've really, really far away galaxies too. Like we're continually pushing the boundary of how far back in time we can see. And it is just kind of mind-blowing the way that it's completely restructuring that subfield of astronomy. It's completely changing the way, like we had some expectations of what we might learn before this telescope launch, but now that we have these data from this telescope, it really is kind of changing the way that we understand the early universe, which then also ties in very beautifully with how we understand how all these galaxies have evolved to what we live in today.
So it's basically, we combine all the observations with the data obtained in order to see back at the beginning of time. That is the main reason of James Webb.
Yes, yeah, it's just such a powerful telescope, and it's so amazing to be able to use it.
Yeah, and another intriguing aspect of Webb's observation is the detailed close-up of the region without any intervening foreground stars. And how was this challenging feat achieved, and how does it enhance the quality of the data obtained and also observed? Because all these foreground stars may provide some mistakes in observations, but because of James Webb power, we don't have these foreground stars.
Yeah, it's really it's a funny challenge in a way. Like you're trying to look at these distant cosmic objects, and you have literally things in our own solar system and our own galaxy that are in the way. So it's very much to some degree, people who work with distant galaxies are kind of used to this. But also one of the beautiful things about the universe is we kind of live in this plane in the Milky Way, and so there's some stuff above and below, but for the most part you can kind of think of it as just like this whirlpool of stuff that's in this one direction. And so if you look above and below, you're kind of looking outside of the galaxy to some degree. And so these stars that are kind of, even the ones in this beautiful image behind you, these stars that are kind of in the way a little bit of like the science that I want to do, they're not as much in the way. And so there's only like maybe one or two in the big galaxy patches that you're looking at. So it's actually, if you're trying to look at something very close to these stars, it does become very challenging. And there's a lot of really impressive work that has been done to try and correct and like remove those stars when you're doing analyses. But for the most part, we're a little bit safe from that. But it really does help having a telescope like JWST that's so much more sensitive to be able to do this a lot better.
Yeah, and we also, that you mentioned, with all that wealth of data and discovery made in just 1 year of Webb's observations, do you think that scientists are utilizing the collected information to formulate new hypotheses about our universe, and also with future observations or probably even space missions?
Yeah, I think there's a wealth of data already, right? I think we're barely scratching the surface of the data that we already have from this telescope.
You cannot process all of them. They are coming, and you.
Yeah, no, like so we're kind of drowning in data in a really good way. Like we have so much beautiful data from this telescope, and we're beginning to pick apart, these really big science questions of, trying to understand the nature of the universe, how we got here, all of these things. And we're starting to be able to do this. But I think there's, even with the data that already exists, that has happened within this first year, there's so much more science that can come out of it. And so really, like, the gift is just going to keep on giving. And what's really beautiful is this telescope will work amazingly in tandem with future observatories that are planned as well. And so it's going to be a continuously amazing, like, beautiful, growing thing, I think. And all of these telescopes will be working really well together and kind of answering these questions.
So thank you very much for these things provided and for chatting with me about the James Webb Space Telescope, which of course we hope that it will discover many things. And we hope that all this data will be processed accurately, and we will find probably something that we never knew in the past, some things that we only dream about. And of course, all these regions in my background, I hope that they will be studied well, and we will discover even exoplanets around that.
Yeah, actually, that's one of my favorite parts. I cannot, like you said, I cannot wait to see what we found that we weren't expecting. Like, what weird thing did we not expect that we're going to find with this telescope? And that's the thing I'm most excited for.
Thank you very much.
Thank you.